Hello everybody, this week we're going to talk about classful addressing. So back in the old days, computers were huge. They took up an entire wall or a room. And when they came up with the IP addressing scheme, they never really dreamed that the average person would have a PC in their home. And here are some quotes like, and this one was from Bill Gates, 460K ought to be enough memory for anybody. So think about how much memory you have in your PC now. Pretty sure most of you have 4 gigs or more. And this is Bill Gates talking about 640K kilobytes ought to be enough for everyone. And I think there's a world market for maybe 5 computers. And this was the guy that was the president of IBM. And there's no reason anyone would want a computer in their home. And this is the guy that was in charge of Digital Equipment Corporation, which was a huge electronics company back in the day. And that's as far as 1977, which is crazy. All right, so back when dinosaurs roamed the earth and the internet was being developed, the computer gods in all their wisdom created 5 classes of address. Now, luckily for us, we're only concerned with the first 3. So the classes are just A, B, and C. And they're based on the first number of the IP address. So the very first octet tells you the class. So if I look at an IP address, it looks like this. So we have 192.168.50.1. So there are 4 octets. This is an octet, 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 octet. So the dots separate the octets. Each octet is 8 bits, as we learned in binary. So the total is 8 plus 8 plus 8 plus 8. So an IPv4 address is 32 bits long every time. All right, so the classes are like this. So the class A IP address range is 1 to 127. So when we look at an IP address, we're only concerned with that first octet. That tells us the class. So if it's in between 1 and 127, we know it's a class A. If it's between 128 and 191, we know it's a class B. And if it's 192 through 223, we know it's a class C. So this would obviously be a Class C address. So again, we're only concerned with this front address. So again, here are the address ranges. Make sure that you have these in your notes. 1 to 127, 128 to 191, and then 192 to 223. So you got to be thinking, well, how do they come up with these addresses? Did they just throw darts at the board and come up with these? Well, for a Class A address, the first digit in the binary is always 0. So we go from 0000000 to 01111, which would be, if we put let me fix this real quick. There. So if we go from 1 to 127 in binary, that's a Class A. So it can never be higher than that because the first bit is a 0. So Class A networks can support up to 16.7 million users, but there are only 127 of them available. So think about that for a minute. A Class A address is either 1, 2, 3, up to 127. So there's only 127 total possible combinations of Class A addresses, and each one will support 16.7 million users. So you got to be asking yourself, well, there's got to be more multinational companies that need more addresses than 127 in the world. And we'll talk about that in a little bit. So that's Class A. So remember, the first bit is always a 0. All right, Class B, the first 2 digits in the binary, it's always 10. So 10, blah, 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 blah. And this, again, should just be 1 to 101111. And that is 128 through 191. Oh, actually, that would be a 0 because that's 128. And then this would be 191. All right. So Class B networks can support up to 65,000 users. So each Class B network will support up to 65,000 users. All right, then we have Class C. So the first 3 digits in the binary, it's always 110. So 110, 110. So that the first 3 are always 110. So that's how they came up with how to split them up. And a Class C network only supports 254 users. All right, so here's what it looks like on paper. So we have Class A, B, and C, 1 to 127, 128 to 191, blah, blah, blah. And then there's also Class D. Now, D class is used for multicast applications. Like when I'm on, let's say, a net meeting or a Zoom meeting or, whatever it is. That if I'm at a business, let's say I'm at a business and there's, thousands of PCs on my network. Multicast is like a one-to-many. So if everybody is on the net, well, obviously not everybody would be on net meeting, but let's say the sales department would be on net meeting, they would be listening on a multicast address. So that's what that's reserved for, multicast. And then E is for some experimental thing. I have no idea where that goes to. All right, so each class has network assigned octets, a part of the address that's shared by all users in the network. So I'm just using X to represent things that we're not concerned about, or the octets that we're not concerned about, or that we're not going to use in this example. So a class A, the very first octet is always network and can never be changed. And then the next three octets can all be changed. In a class B network, the first two octets are permanent, they're always network, and they cannot be changed. In a class C address, the first three octets are network, and only the fourth octet can be changed. And that's why with 3 octets I can support 16.7 million, with 2 octets I can support like 65,000, and with 1 octet I can only go to 254. So when you're given a class A address, or let's say you buy a class A address or whatever, everybody in your network is going to have that same first octet. It can't be changed. So when we get into subnetting later on, just remember class A will always have the same octet for the first one, a class B will always have the same first 2 octets, and a class C will always have the same first 3 octets, and they can't be changed. All right, so each class also has assigned host octets. So remember, with a mailing address like 1313 Mockingbird Lane, everybody on my street has a part that's shared and a part that's unique to the house. So 1313 would be my house address that would be unique to me, or my host address, and then Mockingbird Lane is shared by everybody on my street. So in a class A, we have 3 octets for host. In a class B, we have 2 octets for host. And in a class C, we only have 1 octet for host, which is again why we can do 16 million, we can only do 65,000, and we can only do 256 hosts for each of these networks. And this makes it very easy to split and separate those into host and network portion. So if my IP address was 11.24.15.6, we know it's a class A address because 111 is in the class A range. The network portion would be 111.xxx, and then the host portion would be x.24.15.6. So when you're using classful addresses, which again nobody uses anymore, this is just to kind of get prime and get you going and to understand things. It's very easy to tell like what part is network and what part is host. So let's have you try it. So if my IP address is this, what class is it, and what is the host portion? If you can't get this, you need to go back and watch this video from the beginning, because you have to be able to understand this part. All right, so the first octet is in the class B range, so 156 was in the B range, so the last 2 octets are host, so it would be XX67.100 would be the host portion. That's what's unique to that device or that host. And then the first 2 numbers, 156.23, are shared by everybody in that network. All right, so let's do that one more time. Just make sure you have it down. So if my address is 6.210.134.69, what class is my address? So remember, we're only worried about that first number, so the 6. What range does that fit in? Well, that fits in the class A range because it's between 1 and 127. All right, so how does your computer know the difference? Like, how does the computer know what the host portion is and the network portion is? And it does that by adding the subnet mask. So the IP address is like a lock, and the subnet mask is like a key. And that's what the computer uses to tell it. So a class A address always has a default subnet mask of 255.0.0.0. So the first 255, just like the network part, cannot be changed. But the 000, we can actually modify that if we need more addresses later on. All right, class B always has a default subnet mask of 255.255, and a class C address always has a default subnet mask of 255.255.255.0. All right, again, so these are by default. So a class A has network and then 3 host portions, and then the subnet mask is always 255.0.0.0. Now, a subnet mask is always all ones followed by all zeros. So a 255 is all ones in the first octet, which would be 8 bits. So we also know this as a /8. sometimes on your exam questions and stuff, they will show you like the slash notation. They won't give you the subnet mask. They won't give you 255.255.00. They'll just say, and the subnet mask is a /16. So that's known as slash notation. So again, class B is network, host, and then we have 255.255.00. And again, class B default subnet mask is a /16, and a class C network, 255.255.255, also known as a /24 because it's 8 plus 8 plus 8. So are you seeing a pattern there? So the subnet mask always has a 255 in the network portion. So we have 2 networks, 2 255s, 3 networks, 3 255s. And the reason for that is if you draw the subnet mask in binary, you'll see it's always all ones followed by all zeros. So if we draw it out, and we draw out the IP address above it, any number above a 1 is network, and any number above a 0 is host. So let me kind of show you an example. So here's a class A IP address, 6.210.134.69. So in English, we know that as network host. And then the IP address, so this would be 6 in binary, this would be 210 in binary, this would be 134 in binary, and this would be 69 in binary. So the default subnet mask is 255.0.0.0. So here's the whole thing in binary. And we know anything above a 1, any binary above a 1 on the subnet mask is network. The whole thing got highlighted. So anything above a 1 is network, and then anything above a 0 is host. So that's what the subnet mask does. The subnet mask tells the computer what part of the network is shared by everybody and what part of the network is unique to that individual device. So a lot of the documentation for subnetting has you break everything out into binary and then compare it to the subnet mask. And that kind of gets confusing sometimes, and it's very excessive, and you don't necessarily need to do it. You just need to make sure that you understand that anything above a 1 in the subnet mask is part of the network. Anything above a 0 in the subnet mask is part of the host. So again, the network portion is shared by everybody in the same network, and then the host portion is unique to that individual device. So if we do a class B address, it's the same way. So here we have 150.32 or 23, 234, 198. So in English we say the network, host, and host. And then here's the entire address in binary, and then here's the subnet mask on top of that. So again, anything above a 1 is network, anything above a 0 is host. Now, the subnet mask is always all 1s followed by all 0s. You can never have a 0 and then a 1 in a subnet mask because it doesn't work that way. So the 1s signify network bits and the 0s in the mask signify host bits. So again, each host device needs a unique portion that's unique to them and the part that's shared by everybody on the group or the network. So once things started to picking up, those internet immortals that realized, or that created the internet or created the IP addressing, realized that we would need more addresses. So they came up with private internet addresses that cannot be used on the internet. So they're non-routable. So a router would see these addresses, it would not push them forward. So they came up with some addresses to save the number of addresses used. So for this to work, they also developed a system called NAT, or Network Address Translation. All right, now what NAT does, NAT takes your private IP address and turns it into a public IP address that can be used on the internet. And that's done at the router as your packets or your information is leaving your boundary. So the private addresses are 10.0.0.0, so 10.0, nobody can have a 10 network on the internet. Anybody can use a 10 because it's a private address that's used internally in companies. A lot of colleges use a 10 network. Then there's 172.16 all the way through 172.32, although most of the time you only see that it just uses 172.16. And then for Class C, which is kind of weird, they only do 192.168. They didn't do the third octet. So I've never quite understood why that happened, but they just did. And that's why most home routers and stuff only use 192.168. So most of you recognize your home computer address on that chart. So 192.168 is used for most home wireless routers and access points by default in the US. I don't know if that address is used in other countries, but I would assume so. But if a private address is not routable on the internet, how come I can watch this video on YouTube? Well, that's because your router translates that address to a public address when you send information. So let me kind of show you an example. So I'm going to go to my search bar, type in CMD for Charlie Mike David or command prompt, and bring that up. Now if I do an IP config, and if I can see my keyboard, you see my address is 192.168.50.83. And my default gateway, which points to the closest router, is 192.168.50.1. So we know the 192.168.50 is my network, and 83 is my unique IP address, and then .1 is the unique IP address of the router. So now if I have a private address 192.168. So let's do something different. So if I bring up the internet and I type in what's my IP address, you'll see my IP address is 174.100. So this is what the world sees me as. This is the public IP address, and then this is my private IP address. So my PC actually has 192.168.50.83, but the world sees me as this, and that's because it's translated. When it hits my router, that private IP address is translated. All right, so now you understand that. And the reason for that is, if you think about it, think about all the devices you have at your home that use the internet. Your cell phone, your computers, laptops, tablets, Xbox, PlayStations, a lot of TVs, Alexa, all that stuff needs an IP address. So each of these devices uses a private IP address, but they all share the same public IP address assigned by your ISP. So at my house, like, I've got 2 consoles, I've got 3 PCs, desktop PCs, I got 2 laptops, 2 tablets, and we probably have 3 cell phones. So all those addresses all share the same public IP address, but we all get a private IP address internally on our device. So that's how it saves addresses. Again, and you can test this out at home. So you remember, go to your little search box in the bottom left by the start button, type in CMD. That'll bring up the command prompt, type in ipconfig, all one word, and you'll see what your IP address is. And then if you go to what'smyipaddress.com, it'll show you what your public IP address is. So you can check that out for yourself. And if you take it a step further, imagine a college with over 1,000 computers. Almost all colleges use like a 10.something network to allow them to have. So that's their private network, but they'll all share, one or a few public IP addresses. So when you think about it, and that's pretty neat, the way it functions. All right, lucky for us, NAT is beyond the scope of this particular lecture. All right, but 2 more things to think about. So sometimes you see the range of a class A, like 1 to 126. And this is because 127 is reserved for loopback testing. So every network card is programmed to respond to 127.anything.anything.anything. Now, a lot of times in documentation, you'll see it as 127.001. So if I go back to the command prompt and bring it in the screen, and if I try to ping 127.0.0.1, my NIC card responds to this. And I can type in anything after the 127. I can do 200.150.245. And you can see my NIC card is responding to that, and I'm getting packets back. So the entire 127 range is reserved for loopback. So sometimes you see address like this where it says 1 to 126. That's not correct. 127 is a Class A IP address. It's just reserved for loopback. It can't be used for a company or anything. So just be aware of that if you see 1 to 126 for the Class A range. All right, and again, I already tested it out, but just remember, like in the books and documentation, they tend to just list it as 127.001. So just be aware, it's 127 anything.anything.anything. So the entire Class A range of 127 is reserved for loopback. All right, and then number 2, there's also APIPA, which is automatic private IP addressing. And that is a useless address used by Windows when your computer does not have an IP address assigned and cannot contact a DHCP server, so it assigns itself one. So if you see a 169.254.anything.anything, your PC does not have an IP address. So your computer uses an address to identify itself. it must have an address for the operating system to function. So this is how it handles the lack of an address. So when your computer first starts up, it looks to see if an IP address has been manually put in or what we call statically assigned. So if I go to my network properties and bring this in so you guys can see it, I can go to Ethernet and change adapter settings, and here are my little NIC cards. So if I go to properties, I can go to IP4, and you can hard code an address in here. Now obviously that's not recommended. You're just going to get your one automatically, and your router wireless access point will provide one for you. But that's where you can statically assign an IP address. Years ago, when dinosaurs roamed the earth, a lot of PCs were statically assigned, and that was a pain in the butt. Didn't really work very well. So if you put an address in manually, we call that statically assigned. There are some things that need to have the same address all the time. The email server. So typically your servers, your routers, switches, things like that, your infrastructure devices, printers need the same IP address. So we statically assign those. PCs, though, don't really need a static IP address. So if the address has not been manually assigned, your PC, after it starts up, will broadcast on the network asking for a DHCP service. And that's where the DHCP server assigns the IP address, and we call that dynamically assigned. So your PC can get an address statically assigned, manually put in, or dynamically assigned from DHCP, Dynamic Host Control Protocol. And then if no DHCP server responds, it then assigns itself an APIPA address, and no interconnectivity will be working on that PC. So anytime you see a PC and you do an IP config and its address is 169.254 and it's a Windows PC, you know that it could not connect to anything. The DHCP server didn't give it an address. A regular address has not been assigned. So for some reason, that PC is not connecting on the network. All right, and then, so remember, we talked about NAT, but remember, NAT's a topic for another discussion. We'll have that later. Just make sure at this point you can identify the class of an IP address from its first octet. Given the class, you can state the default subnet mask. So if it's a Class B address, we know the subnet mask is 255.255.0.0. If it's a Class A address, we know it's 255.0.0.0. Make sure you know the list of private IP address ranges, and make sure that you can separate the network and host portions of an address. So make sure you're good with those 4 things before you move on to the next lesson. All right, next week things will get confusing. We'll actually have to do a little bit of math. And we're going to cover CIDR, which is classless internet domain routing, which is what we typically use, what we call real subnetting. Now, don't let me scare you. When I say math, 2 to the power of 2, 2 to the power of 4, so the powers of 2, and then basic addition subtraction, 256 minus 100. And that's the only math that you need for this class, or for subnetting in general. So if you got any questions, let me know. Other than that, have a great week, folks.